look at the 5, 6, and 7. Let's look at the easy guys. So first one, these ones you can all do them. Okay. First one we'll do about oxidation. Okay. Oxidation. Now, oxidation, basically we are going to oxidize with any of these reducing agents. The reducing agents that we have are, we have KMnO4, that's one, KMnO4, or K2Cr2O7, or Na2Cr2O7. These are our oxidizing agents, and you can use any one of them. So that's how easy. Oxidizing an alcohol, use any one of them. So basically what you have is, if you have a primary alcohol, we'll do the cases. Okay, case one is if you have a primary alcohol. Primary alcohol, then you are going to oxidize it all the way to a carboxylic acid. Okay, because carboxylic acid is, you'll be having your carbonyl group at the primary, at the last carbon. So basically we'll have something like this. Let's have it like this. This is the way we have it. We have an OH, which is bonded to, we can put ... to show that it's coming out of the board here. So we say ... R, and then here we put a wedge, okay, to another R, then here we put a line. So there we go. We have it like this. This is a primary alcohol. Why? Because look at this guy. Okay, sorry, this cannot be a, this has to be hydrogens. This is a primary alcohol because look at this guy. I know you guys now know, so it's easy. Okay, you can see my errors and be like, hey, why? So okay, this carbon right over here, look at him. He is bonded to only one other carbon. Okay, this R represents carbon. He's bonded to only one other carbon. So basically, if we oxidize him, he is going to go all the way to a carboxylic acid, but via an aldehyde. So first he's going to give you an aldehyde. And what happens when you are oxidizing? This was important. You are going to remove NH and an OH. Okay? You are going to remove NH and an OH, and you put a double bond O from the same carbon. So I'm going to have that same carbon, ding, 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 to NR. Okay, now I don't even need to put one going out because it's now a trigonal plane. So it's in one plane. So it's like this. R, H. Then we said we remove one H and the OH. We put a double bond O. So we'll put a double bond O, and that's all we have. But this is an aldehyde. Now it's going to go all the way to now the last step where it has the double bond O, it has the R, but this H that you had left will change to be an OH. And that is going to be your carboxylic acid. That's what happens to a primary alcohol. It will oxidize all the way to a carboxylic acid. This is an aldehyde, and here is a carboxylic acid. So whatever we will get, we know what will happen. We check if we are oxidizing an alcohol. Check, is it primary or secondary or tertiary? For secondary alcohol, it only has one step. Okay, what are we going to put? Let's put it, same guy. Here is your OH, wedge, and then here is your line. So in here, I'm going to put R, then H. Okay, so here is a secondary alcohol because he is bonded to two other carbons, this R and R. If you're bonded to two, you are a secondary, 2' secondary carbon. If we oxidize you, bro, let's oxidize him. If we oxidize you, mates, then you are going to form a ketone. So what happens on the ketone? H goes, OH goes. Okay, so you're going to end up having something like this. R, then double bond O. And that's what happens. Then if you oxidize again, you get nothing. You can't oxidize beyond that. That's a ketone. And you are going to end here. It does not go on to anything. What about a tertiary alcohol? What about a tertiary alcohol now? What about a tertiary alcohol? So you have to see what type of an alcohol is it when you're oxidizing. For tertiary, you oxidize, you will get nothing at all. So this is no reaction. Nothing at all. And that's it for oxidation. Okay? That's how easy it is. Now let's see the other one in the next video. I'll stop here for time.